In between what you said, 900 megahertz. I'm giving approximately the range, not exact range. And for 3G, it is somewhere at 1800 megahertz to 2000 megahertz. Okay. And for 4G, it is somewhere 2300 megahertz to 2400 megahertz. Now, what is the operating frequency of 5G? Yesterday, Government of India announced allocation of 5G spectrum to all the service providers. Very soon, we are going to get 5G by the end of this year. The operating frequency of 5G identified.
Greater than 6 megahertz.
Oh, no. The identified frequency is 3300 megahertz to 3600 megahertz for the time being, or 3.3 gigahertz to 3.6 gigahertz. Now, apart from the operating frequencies, which one is good, 2G or 3G or 4G or 5G?
5G.
Why?
5G.
Why? Why 5G is good? Because,
Because it has faster data rate.
yes, data rate. If you look into the 2G data rate, it is somewhere 50 kbps to say 100 kbps, kilobits per second. And 3G comes somewhere 2 megabits per second. And this will be 4G is at some 200 megabits per second, and 5G is 1 to 10 gigabits per second, 1 Gbps, approximately I'm saying. Now, out of all these, in all the mobile communications, we don't use AM or FM. AM or FM is not used because we need high speed, good data rate, good security, etc., etc. Therefore, we go for, instead of analog communication, we go for digital communication. Digital communication. Now, what is the reason that we need to go for digital communications, or what are the advantages of digital communications? Is the very first point is the transmission of the signals. The transmission of the signals is simple, or I can say easy. We can easily transmit the signal compared to continuous wave modulation, whether AM or FM. The second point is we can transmit more than one signal at a time because it is a stream of bits that we are transmitting with different digital modulation techniques. So we can multiplex. We can multiplex. Multiplexing means we can transmit more than one signal at a time. multiplexing is possible. That is the second biggest advantage of going for a digital communication. And the next one is we represent the signal M of t in terms of bits or binary numbers with some code. So the input source or information, the input source or information is encoded. Not only the source, even we add some, what I can say, some additional bits or assume at the receiver there may be a possibility that error occurs. I transmitted 1, but I received 0. That can be detected very easily by adding these extra bits. So such type of yes, such type of coding we call it as channel coding. Okay. So source and channel coding is done such that to detect the error at the receiver, as well as to correct it. This facility is not available in analog communication because there we are calculating the signal to noise ratio. In AM, the noise is already added in terms of amplitude. It is difficult to remove the noise. If it is FM, because the carrier amplitude is constant, we know that we can remove that using clipper. So this facility is available in digital communication. This is another biggest advantage of digital communication. And the fourth point is, as I said, security. Whatever the information you transmit, that is secured. We can have different coding techniques that we can apply before transmission. At the receiver, the same code will be used to decode the information. Whereas in AM and FM, if I use amplitude modulation or frequency modulation, and you are using the frequency range from 88 to 108 megahertz for defense application, the enemy people will use the same frequency band and they tune to the same frequency, whatever the frequency we use. Assume I'm using, say, 100.2 megahertz. It is very easy to tune for 100.2 megahertz, and whatever we are talking, the enemy people can listen. So security aspects, analog communication is not safe. The advantage of digital communications is it provides high security. Then the next one is, assume I have transmitted information from source to destination. So in between, I can provide some repeaters so as to boost my transmitted signal such that it receives at the destination without any error. Such type of boosters are called repeaters. They simply amplify the signal and retransmit it. So this facility is also comes as an advantage of digital communication. Now another advantage is, I said digital. You can store the information. Whatever the songs that you download in your mobile, they are stored in terms of digital bits. not as an analog signal. Keep remember. So the digital communication advantage is you can store messages, you can store songs for longer time. Keep remember, for longer time. Because that information will never get faded, will not get distorted, or will not be decayed. So digital information is always safe. Then as somebody said, in FM, voice quality is good. In digital communication, voice quality is excellent. I can have better voice quality. And all digital systems or all digital communication systems are immune to noise. Because noise cannot do anything with these zeros and ones. Keep remember. Because I have stored the information or I have encoded the information before transmission. So at the receiver also, if there is an error, I can detect the error, I can correct the error. Like that, if I keep on listing, there are n number, only the important things I listed here. So now besides advantages, what are the disadvantages that we can have? The disadvantages of digital communication is that we need to convert the analog signal into digital. My M of t is to be converted into digital form. So in the process, what we do is we don't take each and every sample of a M of t. At regular intervals of time, say at 0 interval, I take what is M of t value. After 10 milliseconds, what is the value of M of t? After 20 milliseconds, what is the value of M of t? So at regular intervals of time, I take the samples of M of t. So as a result, what happens is an error comes into picture, which we call it as sampling error. I'll discuss all these things when we enter into the course. What is sampling error, all those things. And another important thing is bandwidth. Bandwidth is more compared to analog. This also I'll tell why. Okay, we have converted, we sampled the signal, we have converted the analog signal into digital, we modulated at the receiver. At the receiver, I got the bits received, let us suppose binary. So again, I have to sum up them and regenerate my original M of t from the received samples. So there my circuit complexity going to be increased. Complexity of the circuit is increased because we need some sort of what we call it as synchronization of the bits. Okay. Then as I said, we take samples. After taking the sample, say at 20 or at 50 milliseconds, my M of t value is 4.2 volts. Now in the process of digitizing that 4.2 volts, I approximate that 4.2 volts as 4 volts to the nearest value. So that approximation leads to an error for the timing. Let me call it as approximation error. It has another name called quantization error. Okay. Approximation error. So because of this approximation error, when we reproduce the same analog signal, sometimes we may not get the exact analog signal. Okay, so these are the disadvantages of digital communication. So you are all with me? Are you following me?
Yes, sir.
Okay.
Yes, sir.
Okay, fine.
Yes, sir.
So can anyone quickly summarize what we have learned today? I have just given an introduction. I have not entered into the exact actual coursework. Can you quickly summarize? Anyone?
We just recall what is message signal, carrier signal, the differences between the message carrier signal, and you have told us about why we have to use the digital communication apart from analog communication. So advantages and disadvantages of that.
Perfect. Anyone else? There are 178 students in the class. I'm asking to sum up what we have seen today.
Today we learned about the what is modulating signals and its characteristics, and carrier signal and its characteristics different between them,
Okay.
and AM and FM differences between them, and operating frequencies of 5 generations of mobile,
Okay.
and advantages of digital communication and disadvantages of digital communication.
Okay. Good. I think some people kept something in the chat. Sir. Okay. So anyone would like to add something? Two people responded. They have given their summary. In addition to their summary, anyone would like to add something?
Sir,
Yeah,
we
please.
discussed about radio receivers
Okay.
and checking of quality of radio receiver by signal to noise ratio.
Okay. Good.
Sir,
Yeah, please.
we need power to transmit any signal, no, sir. So,
Yes.
we need more power in digital communication or analog.
It depends. Generally, power requirement in analog only, we transmit more power. In digital, what we do is we don't transmit all the time. Okay. That point you will come to know very soon. Maybe in the next 2 or 3 classes, you will come to know because we don't transmit all the time.
Okay, sir.
That is another advantage of digital communication. What you said is correct.
Thank you, sir.
Yeah. So I think we still have some time, so that let me classify the modulation part. Yeah. Modulation. So modulation can be classified as two types. Continuous modulation and discrete modulation. Of course, this continuous part is over in your analog communication, that is your AM, FM, and PM. Amplitude modulation. Of course, angle modulation. In angle modulation, again, you have FM and
Phase and the frequency.
yeah, phase modulation and frequency modulation. Correct. Now, in discrete, we have broadly two types. We have pulse
Yes.
modulation and digital modulation. Keep remember, we have pulse modulation and digital modulation. So our digital communication is purely about the discrete modulation. Let us move ahead. Sub-classification of a discrete modulation. As I said, we have pulse and digital. And again, in pulse modulation, we have two types. Analog and digital. I mean to say pulse analog modulation and pulse digital modulation. In pulse analog, I have all put together three types. Pulse amplitude, pulse width, and pulse position. Whereas in pulse digital, I have pulse code modulation, differential pulse code modulation, delta modulation, and adaptive delta modulation. In digital, I have again, I can say three types. The first one is amplitude, frequency, and phase. Amplitude, I have two types, binary ASK. Here we call it as shift keying, amplitude shift keying, binary ASK or simply ASK, and MRA ASK. Here also I have binary and MRA. So binary FSK, MRA FSK. Now, whereas in phase, We observe carefully here in continuous modulation, we discussed more about AM and FM, but we don't discuss more about PM. Whereas in digital, we discuss little about the amplitude shift keying and frequency shift keying, but most of the discussion is made on phase shift keying, because you take any mobile application, we use phase shift keying. The modulation in your mobile is phase shift keying. So here I have binary phase shift keying, differential phase shift keying, differentially encoded phase shift keying, then quadrature phase shift keying, which is the most popular one and very important. Then quadrature amplitude, which is used now, people are using in mobile communication. And finally, we discuss about the minimum shift keying. So this is your unit 1. This is your unit 2. This is your unit 3 for first mid. Okay. All these things, including BPSK, I think, is your unit 4. And remaining things will come in unit 5. So whatever you are seeing on the screen is your digital communication syllabus. Your first unit talks about pulse amplitude, pulse analog modulation, in which pulse amplitude modulation, pulse width modulation, and pulse position, 3 modulation techniques are there. So we have to look into what exactly the definition of these 3 modulation techniques, how to generate, how to demodulate. How to generate PAM, how to demodulate PAM. How to generate PWM, how to demodulate PWM. How to generate PPM, how to demodulate. And of course, comparison of PAM, PWM, PPM. That completes your unit 1. And in unit 2, the actual encoding part comes into picture, where the analog signal is converted into digital. And then in the previous example, I said the sample value is 4.2 volts. We approximate it to 4 volts. That 4 volts is encoded with some 3-bit or 4-bit binary. So that complete modulation process we are going to see in second unit, a pulse code modulation. A little extension of pulse code modulation. In order to save the bandwidth, we go for differential pulse code modulation, delta modulation, and adapt to delta modulation techniques. So in unit 2 and 3 also, we discuss about what actually the modulation technique is, how to generate that, how to demodulate. Keep remember. Unit 4, amplitude shift keying, frequency shift keying, of course, binary shift keying, all put together. Unit 4. There also we'll see what actually the modulation technique is, how to generate, how to modulate, how to demodulate. Similarly, unit 5. And we have another unit called unit 6, where for all these digital modulation techniques, where we are transmitting the signal at the receiver, somehow binary 1, I have transmitted binary 1, but I have received binary 0, let us suppose. Out of 1000 bits, 1 bit is error. So how to calculate for all these modulation schemes, what is the probability of error? So that probability of error calculation is done in unit 6.